Okay, we've got some u substitution practice problems here. The first one is the integral from -1 to +1 of 3x squared, and that's times the square root of x cubed plus 5 dx. So my first thing is going to be to rewrite it without that square root. Not a huge chore, but we'll change that square root to a 1/2 power. And then we're going to try our u substitution. So we have something in parentheses here, the x cubed plus 5. That's not always 100% guarantee that that's what you need to look at. But when you look at that x cubed plus 5, you see an x squared on the outside, so you kind of see a u du combination there. So let's see, if I let the u be x cubed plus 5, and I let the du, because I have to take the derivative of it, be 3x squared dx, then I can see what the 3x squared dx is, and that needs to be replaced with the du. So we'll replace that with du. So we'll come over here in a separate statement because we don't want to keep those endpoints in u, but we'll replace the 3x squared dx with just du, and we'll replace the x cubed plus 5 with u, so that'll be u to the 1/2 du, integration of that. So in integrating that, the exponent goes up to 3/2. We'll divide by 3/2, which means multiplying by 2/3, and then it's plus c. So in terms of u, the integral is 2/3 u to the 3/2 plus c. Well, let's go ahead and take that plus c off since we have endpoints. But we need to put it back in terms of x. So let's go to x. So we'll have the 2/3 raised to the 3/2, and this is going to run from -1 to +1, and our u was x cubed plus 5. So let's see what happens if we plug this in. If we plug in 1, we get 2/3, and then we have times 6 to the 3/2. That's not going to be a fun thing, I don't think. We'll check it out in a moment. Then it'll be minus 2/3, and when we plug the -1 in, it will be 4 to the 3/2. So let's just double check before we do the hardcore math here. 6 raised to the 3/2 is not a nice number at all. So I'm going to go ahead and evaluate this. So the first part of this, 2/3, 6 to the 3/2 gives me about 9.8. And then 2, 8, 16/3, I believe is the second part, gives me about 5.3. So this is approximately 4.5, if I don't make a mistake there. So we'll go back and double check that, and if you find error, let me know. But after we get it back to x and plug in the endpoints, it looks like that's about what we need to have. Okay, not a bad little integral as far as algebraically, but when you plug the numbers in, they didn't turn out to be super fun. Okay, the next problem here, number 2, is the integration of 1 over the quantity 1 minus 6t all to the 4th dt. So let's look at that. I don't know that we have to rewrite it, but I will because I don't really care for the exponent on the bottom, so I'll bring it up as 1 minus 6t to the -4 dt. Oop. And if that's the case, I'm looking for a u du combination. I'm going to let the part in parentheses be the u. Don't really have much choice. There's nothing else there. So the u will be 1 minus 6t, and the du will be -6 dt. So I don't have a -6 in this problem, so let's manipulate that a little bit more. We'll divide by the -6, so -1/6 du equals dt. So I'm replacing the 1 minus 6t with u, and I'm going to replace the dt with -1/6 du. So in pulling that over, I'm going to have the integration of negative 1/6 u to the negative 4 du. Very simple power rule reversal. Negative 1/6, we're going to raise that u to the negative 3, so we'll divide by negative 3. We'll have a plus c in this one since there's no endpoints, but when I clean that up a little bit, I think it's 1 over 18 u to the negative 3 plus c. So let's take that back to u, in terms of t. So 1 over 18 times 1 minus 6t to the negative 3 plus c. And if you prefer, you can move that negative back to the bottom. So 1 over 18 times 1 minus 6t cubed, and all that's plus c. Okay. If you don't clean it up, it's not that big of a deal, but it helps. So let's sneak in number 3 here. Number 3 is the integration of x squared, and then that's times the quantity of x cubed plus 5 all raised to the 9th dx. I don't see any reason to rewrite that. But I see in parentheses the x cubed plus 5, and I know the derivative of x cubed has an x squared in it, so I'm going to work with that. So I'm going to let my x cubed plus 5 be my u. So in that case, u equals x cubed plus 5, and when I take the derivative, du equals 3x squared dx. Well, I have the x squared dx up here, but I don't have the 3, so I'll manipulate that a little bit. So I'll divide by 3, so I have 1/3 du equals x squared dx, and that kind of matches up perfectly. My x squared dx is going to be 1/3 du. So when I rewrite this thing in terms of u, it will look like 1/3 u to the 9th du. Perfect for reversing power rule. So keep the 1/3. U goes up u to the 10th. We'll divide by 10 plus c since there's no endpoints. So clean up a little bit. We have 1 over 30 u to the 10th plus c. But let's go back to x. So 1 over 30 x cubed plus 5 raised to the 10th plus c. Okay. Looks like we have plenty of time for number 4. Number 4, the integration of e to the x times sine e to the x dx. This is a beautiful little problem. Nice that we have the parentheses there, although it doesn't mean everything to us, but we know how to integrate sine of x, but sine of e to the x, not so much. But we do know that derivative of e to the x is e to the x, so I start to see a u du combination here. So if u is e to the x, du is e to the x dx. So we will put that together. We'll see our substitutions perfectly. So when we switch from x to u, we will have the integration of basically the sine of u du. The integral of sine is negative cosine. So we'll have negative cosine of u plus c. Just need to fix that and say negative cosine of e to the x plus c. So we're going back to the x variables. Okay, one more. Go through half of them here. So we'll do number 5. All right. Number 5 is the integral of secant 2 theta times tangent 2 theta d theta. Well, we do have an integration of secant tangent. I believe that takes us to secant, but with the 2 in there, it's a little bit different. So we'll let the 2 theta be our u, and it's in 2 different places, so we can replace both of them. That'd be nice. So if u is 2 theta, du is 2 d theta. I don't have a 2 on the outside, so we'll make that 1/2 out front. 1/2 du equals d theta. So I'm replacing 2 theta with u, and I'm replacing d theta with 1/2 du. So in pulling that in to u form, it'd be the integration of secant u times tangent of u, and I need the 1/2 out front, I forgot. 1/2 secant u tangent u du. So we said that the 1/2 coefficient will stay there. The integration of secant tangent is secant, so 1/2 secant u plus c. And then we want to take that back to theta. So 1/2 secant of 2 theta plus c. And we'll stop there for this set of videos.